Hey everyone, good morning. I'm excited and humbled to be introducing Track 2, Cloud Native Geospatial in Practice. In case we haven't met, my name is Aimee Barciauskas, and I am a team lead and cloud engineer at Development Seed. I've been there for about 7 years, working with NASA on its adoption of cloud native technologies. And I want to thank Chris for a really great keynote talk where I think each of these tracks, you'll really see how we're actually diving into some of these components that Chris talked about. So we just heard about capacity building. I'm going to dive into some of the challenges in building this cloud native geospatial ecosystem that Chris talked about. And then we'll also hear from Brianna about how to make those infrastructures resilient. So I want to start with sharing why I think we're all here. I think we're all here because we all share a mission to use cloud native technologies to go from data to intelligence faster. But there's a number of challenges to this mission, and I'm going to talk about three challenges that I've identified, three categories of challenge that I've identified. The first category is organizational, and I'm sure you guys are all familiar with these types of challenges, but they're things like there not being any available budget, feeling that new technology is risky, and just generally feeling that users that you want to support depend on existing systems. And I call this I summarize this category of challenge by calling it the change is hard problems. The second category is cultural. So these are the types of challenges that exist across the industry, across individuals and organizations. And these are challenges like in academia, we hear a lot about publish or perish, and just having basically also in private industry, just having the emphasis be on production rather than reproducibility. Also, this general sentiment, I feel like at a lot of different organizations, people feel like, oh, we can't use their technology because we need something custom, or we feel like we can do it better. And just generally feeling that X is more important than building a open cloud and more reproducible approach. And I summarize this by calling this the different values problems. But what I'm going to focus on today and what we'll hear about in track 2 is the technical challenges and the solutions. And there's a lot of technical challenges. So there's different data providers, there's the massive scale of data, there's sending all this data through the network, and then there's different types of users. We have data explorers, we have policymakers, and we have researchers. In addition to this, we have varied data types, varied data formats, and varied cloud providers. And some of these challenges aren't new. They've been around for a while, but the cloud is a new opportunity to try and solve them. I would argue that we as a community here in this room and in our individual organizations actually know how to solve these challenges, which is very exciting. But that doesn't mean it's going to be easy. So to explain why I feel like this challenge is so challenging, I like to use this analogy of shopping in your local grocery store versus shopping on Amazon. So when you're shopping in a local grocery store, it's much like working with data on your local laptop. You go to the grocery store, you know how to navigate to specific aisles and specific shelves. For the items that you need, you take them off the shelf, you put them in your basket, you take them home, you make a meal. This is just like working with data that's on your computer to compute a given task. Now compare this with shopping on Amazon. When you shop on Amazon, there's so many products and they're able to be delivered to so many different places and different people. And this is what makes Amazon amazing. However, Amazon warehouses look nothing like a grocery store. They've designed an ecosystem from the ground, they've designed a system, infrastructure from the ground up that works to solve this challenge of providing different products to different people all over the world. They have different ways of storing that data, they have different ways of packaging that data, and then they have different ways of transiting that data using conveyor belts and a wide system of trucks. So this is a good analogy, I feel, for why moving to the cloud is so difficult. We have so much more data to work with, but having that data and wanting to deliver it to so many different people, so many different places, means that maybe we need to start thinking from the ground up. But what's great is in the next 2 days, we'll hear about technologies that help us solve this great technical challenge, which is to build an ecosystem to discover, order, and deliver this data efficiently in cloud environments. So starting with how can we discover data efficiently, because as this data scales, so will the metadata, and the metadata plays a key part in discovering and using this data. And we'll also hear about how some of these things actually, the metadata and the data actually sort of cross over and interplay a lot. And so we'll hear about how different types of stack infrastructures can address the challenge of scaling your metadata. We'll hear about how different formats like Zarr and STAC both complement and differentiate from each other. And we'll also hear about lessons learned from building a data commons. Moving on to how can we package and deliver this data efficiently, we will hear about some of these cloud-native geospatial formats and some new ideas around them. So things like hearing about Zarr and cloud-optimized geotiffs and cloud-native geospatial vector formats like GeoParquet. And we'll also hear about new ideas. So like Chris mentioned, we'll hear about geospatial support in Apache Iceberg. We'll also hear about use of DuckDB and BigQuery. And we'll also hear about how analysis-ready data can support, and standardization can support the delivery and access of this data through the composable building blocks. And we will also hear about the importance of harmonizing this data for AI readiness, and a really cool tool called ObStore, which will make accessing this data faster than ever. And we'll hear about, now that this data is ready to be delivered, how can we process and analyze it at scale? So there's a number of existing tools like GeoServer Cloud or the Dask X-Ray coiled stack that have been in existence and provide user-friendly interfaces to scaling this data, to scaling data processing and analytics. And we'll hear about how those tools have evolved. But we'll also hear about some new ideas, like using the GPU and using the GPU, as well as building a full end-to-end workflow for hyperspectral data. And very excitingly, we will also hear about how GeoAI is being integrated into these cloud-native geospatial ecosystems. So we'll hear about new cloud services like Amazon Bedrock, which is providing foundational models and how it can be used with AWS Open Data. We'll hear about how AI agents are being integrated into Google Earth Engine. And then we'll hear about a number of different ideas about how generally LLMs, AI agents, and retrieval augmented generation can bring this data, make this data more accessible and make it more actionable. And finally, we need to put the practice into cloud-native geospatial in practice. So we'll hear about some exciting applications, such as the European digital twin of the ocean and how they are using cloud-native to produce an environmental and marine data lake. We'll hear about how cloud-native is being used to support drone data and build the open forest inventory. And we'll hear about how Orbital is using CNG technologies for things such as dark ship detection and GPS detecting GPS and spamming and spoofing events. And we'll hear about how C-Trees is using Zarr for its carbon stocks and emission products, and also how FloodBase is using cloud-optimized geotiffs and STAC for its near-real flood time monitoring. And we'll also hear about radar data also using some of these CNG technologies for weather predictions. So zooming out again, why is it important that we come together to share these technologies? And I would say that even though that we have all these cool technologies that help us derive insights from this data on the cloud, we still need to lower the fixed cost of delivering this data efficiently. Each product has to build their own ecosystem or their infrastructure from scratch. So that's what I would like to talk about here, is how can we basically lower the cost of producing one of these systems for a given new application. In other words, we need to streamline the process of setting up these cloud-native data ecosystems. But the challenge is, how do we do this in a decentralized community? So like Chris talked about, the idea of government used to be potentially owning this type of infrastructure, but we want to do it as this decentralized community that you see here in the room. And to answer this question, I would like to propose the concept of emergence. And in Nick Oblonsky's words, emergence is the way complex systems and patterns arise out of a multiplicity of relatively simple interactions. So this is how a flock of birds creates a murmuration. There's no leader. It's just how they interact with each other individually. And building on this idea is Adrienne Marie Brown, who talks about some of the challenges which are similar to the organizational and cultural challenges that I mentioned at the beginning, which is that many of us have been socialized to understand that constant growth, violent competition, and critical mass are the ways to create change. But the concept of emergence shows us that adaptation and evolution depend on critical, deep, and authentic connections. So that brings me to my call to action, which is to look for new opportunities to learn about and reuse the methods that you hear about here and share these ideas with others. And then in closing, I would like to ask, how can lowering the fixed cost of cloud-native geospatial also help us deliver scientific economies of scale? And in other words, can we industrialize the initial steps of science workflows so the real innovation can happen at the end? And if you're interested in this idea, I recommend also the article Data Science at the Singularity by David Donahoe, which introduces the concept of frictionless reproducibility. A lot of the ideas that the components of frictionless reproducibility that David suggests are very similar to what Chris was suggesting in terms of having benchmark data sets and having leaderboards to basically compare against. So it's the idea that we need accessible data, reproducible workflows, and also milestones to compare each other against, to compare our models against. So with that, I will close and say I look forward to speaking with you all about these ideas and other ideas introduced at the conference, and thank you. And I'd like to pass it off to Brianna.